Hello, in this video we are going to look at solving functional equations, which is like solving equations except with functions. And this is for learning intention number 44. Alright, so I'm just going to look at question 3 in the textbook, and I'm going to use this as the example, and this is for exercise 2i, and I'll just do a few of these and it'll give you an idea of what it's actually looking for. So for example, it might say determine if let's grab this one, f of x minus y equals f of x on f of y. Determine if this holds for, let's take root x. So determine if this is true for f of x equals root x. Determine if f of x minus y equals f of x on f of y is true when f of x equals root x. What is this even asking? What's going on here? What it's asking you to do is check both sides of the equation and see if they work out the same way. So this side is appropriately called the left-hand side, and this side is the right-hand side. So we need to evaluate the left-hand side, evaluate the right-hand side, and see if they're equal or not. So let's do that. The way you do this is you write left-hand side and you do a little colon, and then you copy out the left-hand side. Okay, f of x minus y. Well, this is our function here, so we're going to sub in x minus y into here for x. So that equals the square root of x minus y. Okay, that's our left-hand side. Let's check our right-hand side. So our right-hand side, we copy it out. We've got f of x on f of y, which equals the square root of x over the square root of y. Another way to say that is the square root of x on y. These are equivalent ways of saying the same thing. Now the crucial observation is that this, the left-hand side, does not equal the right-hand side. You can see that they're different. So we say that the left-hand side, we say therefore the left-hand side does not equal the right-hand side. And if you want to be really fancy, you could say, and the identity does not hold. The identity does not hold. So this part is super fancy. You don't have to write that. That part is if you want to be really fancy. This is enough. Writing whether the left-hand side equals the right-hand side or not. Let's have a look at another one. So I'm going to try to pick one that does hold. It's really hard to actually tell. All right, let's see. We'll try to determine if, let's take the identity f of x, nope, hang on, f of xy equals f of x times f of y. Determine if this holds for, and my gut tells me it holds for f of x equals 1 on x squared. Alright, let's see what this is about. Well, we can label the left-hand side and the right-hand side of our equation. Let's copy out the left-hand side of our equation, f of xy, and that equals, well, let's see, we've got to sub in xy for x over here. So that's going to be 1 on x y all squared. And another way to write that is 1 on x squared y squared. Let's check the right hand side. So we copy out the right hand side, f of x, f of y, and there's an implied multiplication there. So we're multiplying the two functions. And so f of x, well, is 1 on x squared times f of y is 1 on y squared. You might notice me sometimes use the dot for times. It's kind of like a more mature times. Like it's what you do for algebra if you want to make it really clear that you're multiplying. So you don't do like an x to get it confused with x itself. It just looks a bit nicer than 1 on x squared times 1 on y squared, because that kind of looks like an x if you're wondering why the dot's being used. Anyway, so that's the same as we multiply fractions by multiplying the numerators to get 1 and multiplying the denominators to get x squared y squared. And look at this, they're equal. So we say therefore the left hand side equals the right hand side, and the super fancy part, and the identity holds. Alright, that should give you a good kickstart to get question 3 done. And if you have been, thanks for watching.